So now metabolic factors and muscle plasticity. So the energy flow of the muscle contraction is to a decrease in the intramuscular energy charge. Obviously, when we use some energy, we have less energy after, yes. When we burn some glucose, we have less glucose, yes. Things like that. And in more molecular level, when you use some ATP, we have less ATP. So we need to recreate this ATP. So it increases AMP-ATP ratio. So AMP is used up ATP. Yes, simple like that. The activation of an enzyme system, AMP kinase, is considered a sensor to the cell's energy status. This acts on the muscular protein synthesis. So this AMP is also the cell also knows there are some receptors for this that there is higher level of the AMP. So one more time, when the ATP, so the shift source of energy of the energy transfer in the cell, is used up, it creates the AMP. Yes, so we have less ATP, we get more AMP. Simple like that. And when we have more AMP, it's also the signal for our cell that we have some problem. Yes, some problem from the cell's perspective. Yes, but from our perspective, it's good because the damage of the muscle, as we said, using up all of this is a starting process for plasticity, for muscle development. So the AMPK pathway stimulates the expression of specific genes. So one more time, yes, expression of some genes, so we have a production of some proteins. And muscle adaptation to increase energy expenditure. Yes, so we are using a lot of energy, so the organism needs to adapt to it. It needs to be able to produce a lot of energy also. So these are mainly about the mitochondrial proteins, because mitochondria are those organelles that are able to produce ATP, to produce the energy. The increase in AMPK activity inhibits protein synthesis during the muscle exercise phase. During the recovery phase, activity in the system rebounds. Obviously, generally, it's no time for regeneration during the activity, yes? Some animals can do it, but humans don't. We are regenerating during rest. So this biphasic action explains the fact that the increase in muscular protein synthesis in response to muscular exercise occurs during the recovery phase. Simple like that. Okay. And another metabolic factor that acts on muscle development is influenced by the level of muscle oxygenation. So how much oxygen is getting into the muscles. It is a hypoxic inducible factor. So magnetic resonance is highlighted the decrease in local oxygen stress at the beginning of the muscle contraction. This local hypoxemia is said to stimulate the production of hypoxic inductible factor. So one more time, we have some factor, some protein generally, that will increase, there will be more of it when we have the hypoxemia, when we have not enough oxygen in the place. And it's natural that during the muscle exercise we would have the hypoxemia because we will use up huge amounts of oxygen. Yes? And this action may favor biogenesis of mitochondria. So one more time, yes, we do not have enough energy, we need more energy. The hypoxemia is the signal for the organism that we need more energy. Yes, simple like that. So the knowledge of the exact role of such metabolic factors shows the adaptation of muscles to the physical training. Yep. Okay. And these elements explain the fact that short, intense, intermittent work helps to obtain metabolic adaptation to muscle exercise. Because we have time to adapt also. Okay, thank you very much.